Welcome to this explainer. Today, we are setting off on a super fascinating journey right into the invisible architecture of our interconnected world. We talk a whole lot about smart devices, and we talk constantly about the cloud, but there is this incredibly powerful, highly complex piece of technology sitting right in the middle that makes modern edge computing possible. It's totally unsung, but absolutely crucial. I want you to really think about this question for a second. How do billions of smart devices, and I mean everything from the tiny sensors in your smartwatch to massive robotic arms and automated factories, how do they actually talk to the cloud without causing just total digital chaos? The sheer volume of data being generated every single second is staggering. If every single device tried to shout its data directly to the internet all at once, our networks would literally collapse in an instant. Okay, let's dive right into this. Just imagine the staggering scale of the Internet of Things ecosystem. We have this massive, chaotic web of connected objects. You've got drones, connected cars, wearable tech, smart homes, industrial sensors, all trying to communicate simultaneously. The scale is almost unimaginable. But thankfully, there's a very robust system in place to tame all this chaos, and that is exactly what we are breaking down today. So here is our roadmap. First, we'll unpack the Internet of Things bridge. Then, we'll see how these gateways work under the hood, explore their core functions and features, break down the actual physical components, and finally, look at some real-world applications. All right, kicking things off with Section 1, the Internet of Things bridge. Let's formally meet the hero of our story. An IoT gateway is exactly what it sounds like, an intermediary or a bridge. It sits directly between your local IoT devices and the broader network infrastructure, like a giant cloud server. But here's the thing, it is not just some passive pipe that data flows through. This gateway is the fundamental component of what we call edge computing architecture. It centralizes all the data from your local devices right at the edge of the network. That means it sits right there where the data is actually being created, rather than thousands of miles away in some remote server farm. And this brilliantly illustrates the whole setup. On one end, your local sensors, things like cameras, thermostats, or industrial robots, are constantly generating data. On the other end, massive cloud servers are waiting to do the heavy lifting. The IoT gateway physically and digitally intercepts the signal right smack in the middle. It essentially acts as the ultimate gatekeeper between your immediate local environment and the vastness of the cloud. Moving right along to Section 2, how IoT gateways work. Now, you might be wondering, why is this so complicated? Well, it's because of the sheer number of different languages that IoT devices speak. It makes the gateway's job incredibly complex. For instance, one smart device might speak Bluetooth Low Energy, while another speaks Zigbee. Industrial systems often use BACnet, but your home automation probably uses Z-Wave. Unlike a basic home Wi-Fi router, the IoT gateway has to act as a universal translator. It listens to all these totally disparate protocols, standardizes them, and then routes the traffic appropriately. So, the data journey basically looks like this. Step 1, your devices collect their raw data. Step 2, the gateway receives it. But instead of just blindly forwarding every single bit to the cloud, it filters it and caches it locally. This is huge, guys. If your internet suddenly goes down, the gateway actually caches or buffers that data, so absolutely nothing is lost. Plus, it prevents the wider network from being flooded. And then step 3, only the essential, highly optimized data is actually sent up to the cloud. Let's jump into Section 3, core functions and features, and see what superpowers these devices actually have. These gateways have some serious jobs to do. First, as we mentioned, it's the ultimate translator, converting different device protocols so completely incompatible devices can suddenly talk to each other. Second, it's a traffic cop, aggregating and filtering data so we don't waste precious bandwidth sending useless noise to the cloud. Third, it's an analyst, performing edge computing to make fast local decisions. And crucially, it acts as a very strict bouncer, managing your network's security. Let's zoom in on that edge computing superpower for a minute, because it's a real game changer. Imagine an industrial setting. A split-second delay in communication there can be disastrous. By running specific algorithms locally on the gateway itself, the system can instantly respond to a triggering event, say automatically shutting down a machine that's overheating. It does this instantly, without having to wait for the data to travel all the way to a cloud server and back. It totally slashes latency and reduces dependency on a perfect internet connection. And here is why this matters so much for security. If every single smart bulb, thermostat, or sensor in your environment were directly connected to the wider internet, each one would be a vulnerable target for hackers. It's a security nightmare. Instead, the gateway acts as a critical, encrypted, and isolated wall. Bad actors hit the gateway's advanced firewall long before they can ever reach your vulnerable end devices. All right, let's take a look under the hood in Section 4, Components of a Gateway. Now, what's really interesting here is that we are not talking about some fragile piece of plastic. Take a look at this, the Advantech UTX-3117 Industrial Gateway. It might be palm-sized, but it is literally built like a tank. These devices are deployed in grimy factory floors, on remote oil pipelines, and tucked away in busy city intersections. They are ruggedized, heavy-duty pieces of hardware built to withstand extreme, harsh environments while processing massive amounts of data 24/7. When you actually break down the components, you realize it's basically a highly specialized, tough-as-nails computer. The hardware packs impressive tech like Intel Apollo Lake processors, and get this, they can operate in extreme temperatures, ranging from -20 all the way up to a scorching 60 degrees Celsius. On the software side, they're running robust operating systems like Linux or Windows 10 to handle the analytics, and they come preloaded to manage specialized industrial communication protocols like MQTT, CoAP, and HTTP. And here is another absolute powerhouse example, the Dell Edge Gateway 5100 series. You'll notice it features these heavy-duty cooling fins on the outside, and that's because these units run incredibly hot while crunching all that data. Armed with dual-core Intel Atom processors, this thing seamlessly aggregates inputs from dozens of different wired and wireless systems. It's constantly analyzing data on the fly and securely sending only the critical insights forward. Bringing it all home with Section 5, Real-World IoT Applications. Let's see where this tech actually lives. So where are these things actually being used? Well, pretty much everywhere. They're the unsung heroes managing complex climate and security systems in smart buildings. They run the entire industrial IoT, monitoring factory floors and global supply chains. They power smart cities, keep modern healthcare monitoring devices online, and track global transportation and logistics. Entire global industries completely rely on these gateways just to function on a daily basis. Think about a smart city environment for a second. You've got traffic lights, the power grid, public transport systems, all generating mountains of data. The gateway is basically the vital organ sitting right between that bustling, noisy city and the internet. It takes the chaotic noise of millions of sensors, secures it, and turns it into real, actionable data for city planners and automated systems, which keeps our urban environments running smoothly and safely. Which brings me to a really fascinating thought I want to leave you with today. As we continue to add billions and billions more devices to our physical world, the cloud simply isn't going to be able to handle all that raw data alone. The future isn't just about building bigger data centers. It's about smarter, much faster edge computing. So are we actually moving the true power of the internet away from massive distant cloud servers and placing it right next to us at the edge? It's definitely something to chew on the next time your smart home instantly turns on the lights. Thank you so much for joining me on this explainer, and keep exploring.